एवरीवन वेलकम टू फिजिक्स एनालिसिस यूट्यूब चैनल। टुडे आवर टॉपिक इज स्फेरिकल मिरर। तो आइए समझते हैं स्फेरिकल मिरर क्या है। राइट, बेसिकली मिरर जो है ना, मिरर आर ऑफ टू टाइप, वन इज प्लेन, अनदर वन इज स्फेरिकल। अब प्लेन मिरर इज व्हाट? सो हुज रिफ्लेक्टिंग सरफेस इज प्लेन। अब लेट अस सपोज दिस इज अ ग्लास, ये ग्लास है, and in this glass this side I have polished this side. That means reflecting surface will become, this side will become reflecting surface. This is reflecting surface. So whose reflecting surface is plane, that we consider as a plane mirror. Now what about spherical mirror? Plane mirror to we know, and we have read the all about the characteristics of image formed in plane mirror also. Now today we will discuss the spherical mirror in detail. Right, so what is a spherical mirror? Means spherical mirror actually the mirror whose reflecting surface is curved. Like you imagine a mirror whose reflecting surface is like this, and this way outside is polished, and it is from inside जो है it is reflecting surface. Okay, so this is a spherical mirror. Now spherical जो है might be concave, might be convex. Why? Because if we are taking a reflecting surface inward, it might be outward also. So here two type of mirrors are there. Means two type of spherical mirrors are there. One is concave mirror and another one is convex mirror. Concave mirror means whose reflecting surface is inward, and convex mirror means whose reflecting surface is outward. So in concave mirror reflecting surface is inward, and in a convex mirror reflecting surface is outward, you can see. So basically mirror are of two type, plane mirror and spherical mirror. Plane mirror means whose reflecting surface is inward. We are showing actually a mirror is made, you know na, a mirror is made by coating a glass, either a side of a glass by silver metal. Most probably we are using silver metal. You can use aluminum also. Reflectance of silver metal is good as compared to aluminum and all. That's why we are using silver metal. So actually we are representing a plane mirror like this. This is a line simply and one dotted line this way. This is how we represent a plane mirror, dash. So this is plane mirror, and this is concave mirror, and this is of course convex mirror, but these two comes under spherical mirror. Now how to define spherical mirrors? Whose reflecting surface is curved. And how to define plane mirror? Whose reflecting surface is plane. So our topic is these two. Okay, this one already we have discussed in detail. Now let us discuss concave mirror and convex mirror in detail. So before going in detail, some terms and what you call the terminology we are using, okay, in formation of images due to spherical mirrors, of course in concave or convex, right? So what are these that we will discuss here. So first of all, focus, principal focus is important to know. Pole is the midpoint of light reflecting area. See, suppose this is the mirror, so simply you can consider the midpoint of plane mirror is denoted by P, and this we call it pole. Now what about aperture? Aperture we have discussed, the dia, reflecting area, dia of this reflecting area, we call it aperture. Now before focus I would like to discuss the center of curvature. Suppose under spherical two type of mirrors are there, one is concave and convex. If we consider this concave, you think how this concave jo hai we have formed, we have how we are getting actually this concave mirror or convex mirror. You can get either by the sectional cut of a hollow sphere, right now. So this is, suppose a hollow sphere is there, you are having a hollow sphere, and you can cut a hollow sphere like this. You are cutting a hollow sphere made up of glass, and you are polishing this way. Either a side is being polished by you, and this is the glass. This is what? This is the mirror. Now tell me, what is this mirror? What is the nature of this mirror? So of course you will say that sir, polished is outside, है ना, outside जो है polished, and from inside जो है it will become reflecting. So this is reflecting surface, and this reflecting surface is inward. Reflecting surface is inward. So of course it is concave mirror. Now the center of that hollow sphere, suppose this is the center of this hollow sphere, the center of that hollow sphere of which this mirror forms a part, that is called center of curvature, C, for this concave mirror. Again I repeat, listen very carefully, okay. I am going to define the center of curvature of this concave mirror. Now if you consider this concave mirror is a part of this hollow sphere, now the center of this hollow sphere is defined as the center of curvature for this mirror. Understood? So the thing is, the center of that hollow sphere of which the given mirror forms a part is called center of curvature of the given जो है spherical mirror, no matter it is concave mirror or convex mirror. In both the cases this is the same. You treat it as same way. Yani the center of that hollow sphere of which the mirror forms a part, that is called center of curvature. You see, if suppose the sectional cut is like this, and you are polishing the surface from inward surface is being polished, so outward will become जो है reflecting. This is reflecting surface, and this reflecting surface is outward, right? So this will become the convex mirror, and this will become the concave mirror. In convex mirror the scenario is same. This mirror, you can consider this mirror is a part of this hollow sphere, right? So the center of this hollow sphere, of which this mirror forms a part, is known as center of curvature of this mirror. So here this center of curvature is this point C is the center of curvature for this mirror, and of course for this mirror also, here in this situation, right? So center of curvature you can define, this is how it is denoted by C. Center of curvature is denoted by, of course, center of curvature is denoted by C, right? And the midpoint of this mirror, we call it pole, P, right? An imaginary line passing through these 2 points, center of curvature and pole. An imaginary line passing through these 2 points, center of curvature and pole, we call it principal axis and the main axis. So principal axis is what? How will you define principal axis? An imaginary line passing through pole and center of curvature. An imaginary line passing through pole and center of curvature. Pole and center of curvature is known as principal axis. You can define principal axis as x dash is the principal axis, P is the pole, C is the center of curvature. Remember, I am discussing for this concave mirror. Same we can discuss for this convex mirror also, right? These are some terminology we are using while tracing images, and of course the formation of images in order to get to know about the nature of image formed in spherical mirror, right? Now this distance from pole to center of curvature, this distance is called radius of curvature, denoted by R. And what about the focus, principal focus? See, light ray coming from infinity. Light ray coming from infinity is assumed to be coming parallel to the principal axis. So light ray coming from infinity after reflection Okay, after reflection meet at which point on the principal axis? See, like these two rays we have considered, which is coming from infinity. These two rays are coming from infinity. So after reflection, through this reflecting surface area, through this reflecting surface, after reflection it will pass somewhere like this, somewhere जो है by this point. So this point is focus. Okay, so how will you define this focus? The focus is that point on the principal axis at which light ray coming parallel to the principal axis after reflection meet. So here you can see this also is meeting exactly at this point, at focus. So if this is incident ray and this is the reflected ray, you can see after reflection these two ray, okay, after reflection through this point of incidence, of course after reflection जो है will be passing through a point. That point we call it focus, right? That point we call it focus. So of course you can say that, sir, why it will go from focus? Actually it has been seen that while in order to, we can say, in order to fulfill the laws of reflection, that also you can say, if we draw a normal, okay, normal means this C to this point, this is the point of incidence. Suppose A is the point of incidence, okay, this ray is being incident at this point A. From A to C, this ray is this point, this line is what? This line is nothing but normal. Array, if suppose this concave mirror is a part of this hollow sphere and you are treating this point as a we are calling this point as a center of this hollow sphere. So center to any point, line joining center to any point on the circle is considered radius, right? And radius is perpendicular to the the tangent. So actually it is perpendicular to this point, at this point, and this way this will become angle of incidence. Now how much is the angle? The same angle is this, right? So in order to fulfill laws of reflection of light, there is no other option other than passing through this point only, right? So that is why light ray coming from infinity parallel to the principal axis, of course, after reflection will pass through focus. This is the thing. So this focus we have discussed. Finally, how to define principal focus? So principal focus is, this question is there. Okay, you can consider, if I am not wrong, page number 168 NCRT. In some book, of course, 168, in some book 142, because you might be using different books. Okay, the new edition जो है page number is different might be, but inside question answer this question is there to define principal focus of a concave mirror or convex mirror. So how will you define? You can say like that, it is the point on the principal axis at which light ray after reflection meet or appear to meet. So that will be for that case will be for convex, in case of convex mirror. So light ray after reflection meet at which point on the principal axis, that is called, of course, the principal focus of concave mirror. But when someone will ask you to define focus on a convex mirror in virtual point of view, okay, there you can say that the point on the principal axis at which light ray after reflection, at which light ray coming parallel to the principal axis, that point you add. Light ray coming parallel to the principal axis after reflection meet or appear to meet at focus. Either it is meeting exactly, okay, and this is, you know, this is really it is meeting, main line after reflection, main line, bold line, it is meeting, no dot line, it is main line. So after reflection directly it is meeting at a point, actually they are meeting. We are seeing that after reflection these two rays, after reflection these two rays are meeting. So this is the main actual meeting. So this is the focus for concave. Actually focus is defined, principal focus is defined as the point on the principal axis. It is the point on the principal axis at which light rays after reflection, I mean of course light rays coming parallel to the principal axis, after reflection meet or appear to meet. See, I am showing you in case of convex. Suppose light rays coming like this light rays are coming. Okay, so after reflection, let me first draw the this is the point for this P, and if suppose this is the center of curvature for this mirror, let us suppose mm dash is the mirror. For this mirror, see the center of curvature, and see I am telling you this f jo hai na, let us suppose if this is my f, of course this is the f of this this mirror. So at this point, this point is exactly the midpoint of this PC. Later on we will come on the topic जो है what it is happening geometrically we will show that also. But now I am telling you this PF is equal to CF, right? This distance is equal to this distance. Okay, this distance is equal to this distance. So if this is radius of curvature R and this is the focal length, of course the distance between pole and focus is known as focal length, and the distance between P and C, that is called radius of curvature. And here R is equal to twice of F, and of course F is equal to R by 2. This is the relation between focal length and radius of curvature. That also you can get to know here, that these two are related to each other. Radius of curvature is double, means twice of this focal length, right? And focal length is the half of the radius of curvature. So you can write R is equal to 2F and F is equal to R by 2. Okay. Acha. So these two rays are coming parallel to the principal axis. After reflection, these two rays will be going like this, like this, like this. When traced back behind the mirror, it will appear to meet at a point exactly on the principal axis, and this point we call it focus. Ray diagram. In spherical mirrors, right? So what are the rules are there? See, the first rule, when the light rays, suppose this is the concave mirror, okay, this is the concave mirror, and when light rays will be coming parallel to the principal axis, this is rule number 1 I am telling you, okay na? And these rules you listen very carefully, because why? Because we are going to use and utilize these rays, these जो है rules in tracing the images, right? So this is the first rule. So as per the first rule, when the light rays will be coming parallel to the principal axis, after reflection it will pass through focus only. So if suppose this is the focus, and this is how light ray is coming, which is parallel to the principal axis. So after reflection, passing through focus only. This is rule number 1. Same you can you can see in case of convex mirror also. Suppose this is how one light ray is coming. So after reflection, suppose this is the focus and this is the center of curvature. This after reflection it will go along focus only. Here also it is going along focus. So when traced back behind the mirror, it is appearing passing at focus only. Here also light ray which is coming parallel to the principal axis, after reflection passing through focus only. So this you always remember. And sometime they are asking question also in CBSE, right? That this is how they will draw the diagram. One light ray is being incident at this point, and they will leave the incomplete diagram, and they will leave on you to complete the diagram. So you can complete by tracing this line, by joining this line. So this is the point of incident at which this light ray is being incident. After reflection it will pass through focus only, you know that. and this is how we define focus also, that it is the point on the principal axis at which light ray after reflection जो है meet or appear to meet. Here in case of appear to meet, and here it is actually meeting. Okay, so this is rule number 1. So rule number 2 is what is rule number 2? So rule number 2 is when the light rays see, suppose this is the focus and this is the center of curvature, and of course this is the pole, and this is the mirror, dash is the aperture, x-axis dash is the principal axis. So we have this mirror, and these are the parameter of this mirror. Let us consider a concave mirror dash, whose pole P, focus F, and C center of curvature, and P, of course, x-axis dash is the principal axis. Now if any of the light ray passing through center of curvature, it will retrace its path. Okay na, suppose this is how one ray is coming, passing through center of curvature, and this is the incident ray. So you know now, we have discussed already, just before this we have discussed that the concave mirror is nothing but a part of a hollow sphere. Suppose this is a part of some kind of this hollow sphere, and this is the center of that hollow sphere, and center to the tangent, the line drawn, the radius is the perpendicular to the point of touching point. This is tangent. So this is the parallel, and you know, according to principle of reversibility, suppose this is the mirror, this is the plane surface, and any of the light rays incident normally to the surface, it will retrace its path. Okay na, according to principle of reversibility. Here also same case. So that's why this light ray was coming, okay na, when the light ray will be coming from the center of curvature, passing through center of curvature, then after reflection it will retrace back along the same path. Okay na, along the same path. Same for a convex mirror also. If we draw a convex mirror, convex mirror, this is the convex mirror, this is focus, this is the center of curvature, and this is the pole. Suppose one light ray is coming in this way. In this way, one light ray is striking on this point. This light ray is being incident at this point. Okay. Now what happened to the reflected light? What do you think? क्या लगता है किधर से जाएगा? Actually, it is coming along the center of curvature. You can see here. It is being incident here along the center of curvature. That means it will retrace its path. Understood? It will retrace its path. So here also you can see it is retracing its path along the same way. Here also. So that means any of the ray that is passing through center of curvature, after reflection it will go along the same path. Here also it is after reflection it is going along the same path. So these two rules are very much important. Okay, now while tracing image, ray diagram for this spherical mirrors, right? And same way the reverse is also true. Okay, any of the light ray coming from focus, after reflection it will, like here only I am showing you, suppose any of the rays that is coming from focus, so after reflection what do you think, where it will pass? After reflection it will go parallel to the principal axis. You can see this is how one light ray was coming. After reflection it will go from it will go parallel to the principal axis. So if light ray is coming parallel to the principal axis after reflection passing through focus, the reverse is also true. Any of the light ray passing through focus after reflection, it will go parallel to the principal axis. The reverse is also true. Same way here also, one light ray was coming parallel to the principal axis. After reflection, you can see passing along the focus only. So if here also any of the ray that is coming from focus after reflection, passing after reflection, it is assumed to be going parallel to the principal axis. Move on. Next one is we have discussed the terminology we are using while tracing the images. Second one, rules we have discussed. Now we can go for formation of image, right? Okay, so now we can discuss image formation in spherical mirrors. Image formation of image in spherical mirrors, right? So one by one we will see. First of all, let us see image formation in spherical mirror, means concave mirror. Okay, concave mirror. So one by one we will discuss, right? See, actually nature of image formed due to spherical mirror depending upon the position of object placed in front of the mirror. Now let us suppose this is one of the mirror, okay, and let us suppose this is the mirror dash whose pole P, and this is the focus, and this is center of curvature. Of course this is principal axis x dash, right? So what is the nature of image formed of an object which is being placed, of course, in front of the mirror? If we want to know the nature of image formed due to this spherical mirror, this is concave mirror, of course. Listen, I am telling you the nature of image formed due to this spherical mirror, no matter it is concave or convex, depending upon the position of object placed in front of the mirror. So what are the possible positions where an object can be placed so that its image will be formed? So these positions, maybe I can place one of the object here, exactly at focus I can place, in between center of curvature and focus I can place, one more point is there here exactly at center of curvature, and beyond center of curvature one object I can place, or else we can place an object beyond center of curvature, I mean beyond we can call it infinity. So when the object is placed at infinity, then what is the nature of image formed? When the object is placed beyond center of curvature, means of course in between somewhere beyond center of curvature and infinity, somewhere on the principal axis, if the object is placed, then what is the nature of image formed? Next is, so this is position number 1, this is position number 2, and this is position number 3, this is position number 4, and this is position number 5, this is position number 6. So total this many 6 positions are there where you can place the object so that its image would be formed, right? So these are the possible cases. So 6 possible places are there. So we will discuss 6 possible cases where you will place the object, because of that image will be formed. So what is the nature of image formed due to the object placed at different positions? Let us see one by one. Okay, so let us first discuss when the object is placed at infinity, right? So case 1, when the object is placed at infinity. So when the object is placed at infinity, then what about the nature of image? जो है, see, suppose this is the concave mirror, right? This is the concave mirror. ध्यान से सुनना, it is very important, right? This is the pole and this is the focus, this is the center of curvature, dash. this is xx dash. So let us consider an object is placed at infinity. So light ray coming from infinity assumed to be parallel to the principal axis, parallel to themselves, right? So when the light ray coming from infinity, of course parallel to the principal axis, after reflection it will pass through focus only. So here this light ray after reflection passing through this point where an image will be formed. And why? Because this is the point of intersection, of course, of reflected rays, and you know that the meeting point of reflected ray forms an image. So here is the meeting point of these two reflected ray, so the image will be formed here at focus. Now listen, let us consider a concave mirror M dash whose pole P, focus F, center of curvature C, and principal axis xx dash. Let us suppose an object is placed at infinity and light ray coming from infinity, from that object, of course. After reflection, both the ray meeting at focus exactly where an image is formed. And since this is actual meeting, so this is real image, and real image we are considering inverted. Of course it is very diminished, extremely diminished, point size you can call. So no matter it is erect or inverted, but real image is always inverted. So that's why we are here we consider that real, inverted, and very diminished, highly diminished you will write, point size, of course. Okay, so what is the position of object? This way you will write. In exam also they are asking what about the nature of image formed when the object is placed at a different position, like that they are asking questions also. So position of object you will write. What is the position of object? Tell. Position of object is at infinity, and what is the position of image? What is the position of image? So position of image is at focus, and what is the nature of image? This is the most important thing, nature of image. So the nature of image you will write real, inverted, and highly diminished, almost point size. So this is case number 1, bacho. We have discussed this case number 1, when the object is placed at infinity, then what is the nature of image formed. So when the object is placed at infinity, the image will be real, inverted, and highly diminished, point size. This is how you will write position of object at infinity, position of image at focus, and the nature of image real, inverted, and highly diminished. This is case number 1. So I hope you understand. See, I am showing you by these two rays. Don't consider that only these two rays are coming from the object, right? A number of, suppose this is the object. Object are of two type. One is point size means dot point. This is the point size object, and this is the extended object. So this is extended object. So in extended object, so many points are there, right? From the header part to the footer part, so many points are there. Let me tell you that from every point from this object, from every point जो है light rays are, this every point जो है emit light in all possible direction. Not only one or two, billions of light rays are coming from each and every point there in this object in all possible direction, not only in a particular direction. But here, since this side mirror is there, so why to consider this way, blah blah, light rays are coming here, in here. Okay, why to consider? Only two rays we are considering, because our target is to form an image. An image is being formed by meeting of at least 2 points. Meeting is possible by either by 2 or more. So we are taking only 2. But if you consider more light rays, so I am telling you, after reflection all will be passing through this point only, right? This is the uniqueness of this point, and we call it focus. You see, I am showing you. But in the exam, you will draw these 2 points only. Don't draw so many points. Okay. See, one more ray I have taken. One more ray I have taken. One more ray. One more ray. One more ray. So these many rays जो है we have taken, and these rays all are parallel to the principal axis. So after reflection, all will be passing through focus only. You can see, all will be passing through focus only, right? All are passing through focus only. See, and here image will be formed. I hope you understand. So this is case 1. Now we shall discuss case 2, right? So case 1 is when the object is placed at infinity. Now let me tell you that as and when light ray, as and when object is being placed closer to the mirror, the size of image will go on bigger. We will discuss. Okay, let me rub this one. So case 2 is when the object is placed beyond C, right? So when the object is placed beyond C, so we have a concave mirror like this. We have a concave mirror, right? This is mm dash, this is pole P, focus F, center of curvature C, and principal axis xl dash, right? So let me consider that a concave mirror is there. Mm dash is the concave mirror. Okay, of course this also making it perfect, right? So let us consider a concave mirror mm dash whose pole P, focus F, center of curvature C, and principal axis xx dash. Now let us consider one object is placed beyond C. So let me consider one of the object AB which is placed beyond center of curvature. This is center of curvature, you can see, and this is the focus, and this is the point pole. And let me assume that AB be the principal axis, AB be the object which is placed beyond center of curvature. Now light ray coming from AB, you see, light ray coming from AB after reflection passing through focus. Okay, so this we know, we have read that light ray coming parallel to the principal axis after reflection passing through focus only. We have read, okay, rules for tracing the ray diagram. So one ray we can easily draw one of the ray coming from the object, and this ray you can draw parallel to the principal axis. Why? Because you know already that ray, any of the ray which is coming parallel to the principal axis after reflection, it has to pass through focus. So that you know. So we have one reflected ray. Now one more reflected ray is required in order to get a meeting point. So for that, what is easy to take? Actually, let me tell you that from this object at every point, okay, now every point present in this object, okay, emit light ray in all possible direction. This point, okay, this point, from header to footer, all the points present in this object, okay, emit light in all possible direction. And not only a single light, billions of light rays, okay, are coming out of every point present in this object in all possible direction. But we are considering out of these many rays, we will consider one ray which is coming parallel to the principal axis. Why? Because we know that this ray after reflection will be passing through focus. So this way one ray we can easily get, one reflected ray we can easily get. Now one more reflected ray we want. So for that, why don't we consider this ray that will be passing through center of curvature? Why? Because we know that when a ray passing through center of curvature after reflection, it will retrace back in the same medium. Yes or no? So now this ray will become reflected ray for me. See, from here it was incident ray, but after reflection, same along the same path it is going. So now this ray has become जो है reflected ray, and this is the reflected ray another. So this and these two reflected ray are meeting at this point. So here image will be formed. Now these two rays was coming from the head part, from the header part. So here header part of the image will be formed. So if it is AB, you can write here A dash B dash. Right? This I am rubbing so that you will understand this one. So now let me consider one of the object is placed beyond center of curvature. Light ray after reflection meeting in between C and F somewhere where a image will be formed, and this image you are seeing, this image is being formed by actual meeting of these two reflected rays. So this image is real image. This image is real image. So I will write here position of object. Position of object. So what is the position of object, बच्चों? Beyond C. And what is the position of image? Position of image. What is the position of image between C and F? Between C and F. And what about the nature? What about the nature of image? So nature of image is real. Of course real है तो inverted and diminished बच्चों, है ना? Diminished. Don't say highly diminished. Why? Because this is not a point size. This is comparatively smaller as compared to the object. So here you can use the word diminished, right? So what is the position of object here? Position of object is beyond C. You can see here object is placed beyond C. This is the C point. And what about the position of image? Position of image was between C and F. Position of object was beyond C. And what about the nature? The nature is real, inverted and diminished. This is case number 2. But you see the image very carefully. Why? Because I know students are making mistakes for drawing the diagrams. Okay. So this first ray you will take parallel to the principal axis. Why? Because you know that after reflection it will pass through focus. And second ray you can take ray passing through center of curvature, that will be after reflection it will retrace back in the same along the same path. So this way this will become the reflected ray and this is the reflected ray. These two are meeting at this point where an image will be formed, and these two ray was coming from the header part. So the header part of image will be formed. So this is the real image. This is see, if it is erect, so it is inverted. You can see this is, if it is erect then it is inverted, है ना? ये थोड़ा inverted image बन गया. This is the object height and this is the image height. Okay. So let me conclude this case 2. Case 2 is basically when the object is placed beyond C. So when the object is placed beyond C, you can see in this diagram light ray after reflection meeting in between C and F where a real, inverted and diminished image is formed. This is the size of image, okay, and this is the nature of image, and this is the position of object, this is the position of image. Now let me disturb this image. Okay, see, I am showing you the figure will come up very unique. You see, one of the more rays, if we consider more rays that is coming from this object, see, and in the paper you draw these two rays, that is enough. But here, just in order to show you, I am showing you more number of rays, okay na, coming from this object, more number of rays, and the result will be very satisfying. You see, result will be very satisfying. Okay na? These many light rays I am considering coming from this point, and this is the object. These many light rays. Now you know what? All these light rays, these are incident after reflection. Will be passing. I mean, will be meeting at this point exactly. You see the result, and the result is very satisfying. This. You see, if this is object and this is, then this is the image. All the light rays after reflection meeting exactly at that point only. See how it look like. The result is very satisfying. Okay na? So this is case number, of course this is case number 2. Sorry. This is case number 2 when the object is placed beyond C. So when the object is placed beyond C, then the nature of image will be real, inverted and diminished. Right? This is case number 2. Okay. Now let me rub this one and let us move on to the case number 3. Okay. Clear? Case number 3. What is case number 3? Now see, once we have placed beyond, beyond the center of curvature and infinity also. Case number 3 where we can at C exactly, right? This is the case. So when the object is placed at C exactly, at C, okay na? When the object is placed at C. So when the object is placed at C, then what is the nature of image formed? Let us see. We have one concave mirror, of course. This is the concave mirror. So let us consider a concave mirror mm dash, right, whose pole P, focus F and center of curvature C. X axis is the principal axis. Now one object is placed exactly at center of curvature. Now you see light rays coming from center of curvature, from this object AB, of course it is AB, after reflection, okay, passing through focus this light ray. So let me draw a point passing through this focus. Okay na? So light ray coming parallel to the principal axis after reflection passing through focus. Now one more ray we will take in order to form an image. So this second ray I am taking passing through focus. See, this is the incident light and reflected light will be parallel. Reflected light will be parallel. Reflected light will be parallel. It is passing somewhere here. Okay now? Here, and here image will be formed. So if it is AB, then this will be A dash B dash, A dash B dash, right? And you can see height of object is equal to height of image. See, this is the rays passing through focus. So you might be thinking, sir, in the previous cases you have taken this light ray in the same path after reflection. No, 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 this is focus. So when the light ray is coming from focus, passing through focus, after reflection it will go parallel to the principal axis, just opposite to the case 1, means opposite to the rule 1. So what was rule 1? In order to trace the image, one light ray coming parallel to the principal axis, after reflection passing through focus. So when the light ray passing through focus after reflection after reflection it will go parallel to the principal axis. Now this ray is the reflected ray and this ray also is the reflected ray, and these two are meeting exactly at this point where image will be formed. So you can see here position of object. What is the position of object? What is the position of object? The position of object is at C. What is the position of image? The position of image is also at C. And what about the nature of image? What about the nature of image? The nature of image is real, inverted and same size, right? You can see here same size of image is being formed. All right, same size of image is being formed. Written. Okay, now I would like to disturb this image, of course. In this case also let me disturb the image. Okay, so I am taking more number of rays and you see how it look like. So don't you consider that only 2 rays we are taking. If you will consider more number of light rays coming from this point, after reflection you can, no matter you are taking how many number of light rays, all the light rays after reflection meeting exactly at this point only where image will be formed. You see, I am taking one more light ray, this is one more this, one more this, and one more. So this many light rays we have considered, and this all the light rays are passing, no matter from where it is passing, but all the light rays are coming from this point. So I am telling you, all the light rays after reflection will meet exactly at this point only. Don't you surprise? You see the result. Oh my God. And satisfying. Yes, right? So no matter how many light rays you are considering, all the light ray after reflection meeting exactly here only. From here I have taken, suppose this many. Suppose if you will consider billions of light rays coming from this point, so all billions of light ray after reflection meeting exactly here only. So that's why we are saying when the position of object is at C, then position of image will be at C exactly. Okay, when the object is placed at C, image will be also formed at C. And what is the nature of image? The real, inverted and same size. You can see here same size. If it is 5 centimeter, then image will also 5 centimeter. Clear? Can I rub it? Okay. So let us move to case number 4. Case number 4. So first let me rub. Why? Because I forget. Case 4, when the object is placed between C and F. C and F. Okay. When the object is placed between C and F. So okay, I am rubbing. Just between C and F. Okay, so let me take one concave mirror. This is one of the mirror. this is mm dash concave mirror, pole P, focus F, and this is center of curvature. Of course, it is principal axis x dash. Now, what was case number 4? Object is to be placed where? Between C and F. So, I am considering one of the object is placed in between C and F somewhere, and of course, it is AB. Okay. So, case number 4. See, we have an object, we have a mirror, concave mirror. So, let us consider a concave mirror mm dash, whose pole P, focus F, center of curvature C, and principal axis x dash is there. Okay. Now, let an object is placed in between C and F. Then, light ray coming from this object after reflection, let us see where they are meeting. So, wherever they are meeting, their image will be formed, right now. So, let us see where they are meeting. So, one light ray I will take, I would like to take parallel to the principal axis. Why? Because I know that light ray coming parallel to the principal axis after reflection passing through focus. So, let me okay, that's good. This light ray is passing through focus. Okay. Now, where to take one more light ray? See, you have, what are the possible option you are having? You can take this ray that will be passing along the center of curvature, keeping in mind that this will retrace back in the same medium. Now, that will be your reflected ray, and somewhere it will meet from this. So, their image will be formed. Another ray you can consider passing at, here only is being incident. You can make this incident light to be incident at this point. So, on following law of reflection of light, it will pass like this and their image will be formed. So, this ray, if I will consider this ray, I don't know what will be the angle, what is the measurement of angle. So, this way you can make a mistake. So, rather than taking this ray, of course, you can take third ray, you can consider, but second ray you prefer this one, right? Keeping in mind that it is passing along this center of curvature, then it will retrace back and somewhere it will meet. See, I am showing you. So, second ray I would consider this, because I know, okay, that it will come back along the same path. See, and you can increase these two, and you can see these two are meeting exactly here somewhere where an image will be formed. So, if it is AB, then it will be A dash B dash. This is A dash B dash, right? So, this is your incident ray, but now it has become reflected ray. And if this is the incident ray, this is the reflected ray. So, we have this reflected ray, we have this reflected ray. These two reflected rays are meeting here at this point. So, image will be formed at this point exactly, right? And how this image look like? This is magnified. How this image look like? Magnified. So, here position of object, what you will write? Between C and F, between C and F. And what is the position of image here? Position of image you write beyond C. And what is the nature? So, nature, of course, it is real, inverted, and magnified. So, rather than writing same, here I will write magnified. Clear? This is the position of object, position of image, this is the nature of it. Position of object was between C and F, position of image is beyond C, and nature is real, inverted, and magnified. This is case number 4. I hope you understand, right? Position of object was where? Position of object was in between C and F. What was the position of image? Position of image was beyond C. You can see beyond C. And what is the nature? So real, inverted and magnified. Now same way we can disturb. Same way you can disturb here also. If you will consider more number of light rays, you consider this light ray, this light ray, this light ray, this light ray, this light ray. Okay, no matter how many light ray you are considering, but I am telling you all the light ray after reflection meeting exactly at this point, right? Meeting exactly at this point. So see, somewhere this light ray somewhere is nearby a focus. So this reflected ray will be like parallel type. See na, little bit differ, but it is like parallel. Why? Because this light ray is nearby focus. Like that, another light ray after reflection they will perform like that, and you can see how satisfying look is there. This look is coming, right? So if it is object, then this is the image. So how many light ray you will consider? Okay, no matter as many light ray you will consider, after reflection all the light rays to be meet there only where an image will be formed. Clear? Clear everyone? Okay. So let us move on to case number 5. This is case number 4. This is case number 4. Here the image is bigger. I mean h dash जो है, h dash is more than h, where h dash is the height of image and h is the height of object. So if h dash is more than m, then more than h, then magnification will be more than 1. Magnification is more than 1. Magnification you will later on we will discuss. M is equal to h dash by h, and if h dash is more h compared to height of object, so here m is more than 1. So if m is more than 1, you consider that height of image is more h compared to object if magnification is more than 1. Clear? Get it? I am telling now only. Actually after this you will come to know the mirror formula, of course. After that you will read magnification, but before only I am trying to make you understand. I am writing little bit magnification also. I am telling you why, because you will understand here from figure how magnification is जो है magnification vary है ना as per the cases, right? So in case number 4 magnification value will be more than 1. Okay, so let us move on to case number 5. Okay, so what is case number 5? Tell me, case number 5. Case number 5 is what? So case number 5 is, what are the cases left? One, this one done, this one done, this one done. Case focus. Okay, so when the object is placed at focus, when the object is placed at focus, right? So this I am leaving as it is. This only I am rubbing at focus, position of object. Let us see what is the position of image, and let us see what is the nature, right? So for that I am rubbing this diagram. Okay, so case 4 is when the object is placed at focus. So let us consider one concave mirror, right? So let us consider a concave mirror mm dash whose pole P, focus F and center of curvature C, of course, and principal axis x dash, right? Okay. So now in this case 5 we are considering object to be placed exactly at focus. So if we place an object at focus, if we consider an object is placed at focus, then light ray coming from this object AB, let us consider this object AB. So light ray coming from this object, one light ray you take parallel to the principal axis. Of course, after reflection it will pass through focus, right? So this is one of the reflected ray we have got. This is the incident light and this is the reflected light. Now we are going to form an image. So in order to form an image, what we need? We need a meeting point of reflected ray. So this we have one reflected ray, one more reflected ray if I get, and these two are meeting somewhere, then there will be image. Okay. Acha. So this one more ray, can we take this one passing, that will be keeping in mind that this is passing along the center of curvature, so that it will retrace back in the same along the same path and passing by the center of curvature only. Okay, by the center of curvature only. So these two rays are parallel and these two rays are not meeting, but you can assume that all the light rays are meeting at infinity. Okay, so this case number 5 we are considering object, position of object to be placed at focus. So position of image will be at infinity, at infinity. This is like when the object was placed at infinity, na? So how the image was being formed at focus, yes or no? So same way we can consider that if the object is placed at focus, then jo hai image is to be formed at infinity. Now I am showing you how we are considering why the image is being formed by, why? Because they are not meeting here. You see, light rays are coming from a point source. If we consider a sun as a point, okay, as a point, and light rays coming from that point in all possible direction, but after traveling this such a longer distance, okay, it is assumed to be coming parallel, yes or no? So here why don't we consider this many parallel rays, okay, meeting jo hai at a point where the image will be formed actually. So here the image will be formed at infinity. Okay, so you will write position of object at F, focus, position of image will be at infinity, and what is the nature? Nature will be of course real, inverted and highly magnified. Not only magnified, highly. Okay na? So here you will write highly magnified, highly magnified. बहुत ही बड़ा इमेज बनेगा. Okay, I am going to disturb this image. Okay, these two rays I am considering, but what if we consider more number of rays, okay, coming out of this object? So let me consider more number of rays. I am considering one more ray here, 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 here it already is there, here. Okay, so I am considering one more ray, this one ray is this, one ray is this, one ray is this. Again one of the ray is this, 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 this. See, all these rays are coming, all these rays are coming from the object. Okay. Now after reflection, all the rays will be passing like that, like that, like that, of course this ray, of course it is parallel, this ray also. You see, all the light rays are going parallel to each other. All the light rays are going parallel to each other. You see, right now. So we have taken one of the object which is placed exactly at focus. So light ray coming from this object, after reflection they will meet, we can consider they are meeting up. Here I am showing you this many distances in between these two rays. Do you think this much distances are there in between two two rays, between the rays? These many distances are there? No, na. They are like very, they are assumed to be meet. They are considered to be meeting at points at point at infinity, of course. So when the object is placed at focus, image will be formed at infinity, and that will be real inverted and highly magnified. Okay, this is the case number 5. Note it down. Okay. Well done. Now let me consider case 6. So what is case 6? Case 6 is when an object is placed in between P and F. Okay, now between P and F. P means pole and F means focus. So when an object is placed, this I am rubbing this one. When the object is placed between P and F, let us see what type of image is being formed, right? What type of image is being formed? Okay. So this is case 6, and with this is the last case of this. I know the video is very long, but what to do, we are writing actually. See, this is case number. I know this is the video is going to be very long, but what to do, we are writing on board, that's why we are getting late. Okay, see, so this is concave mirror, and this is pole P, focus F, center of curvature C, and principal axis x. So let me consider one object is being placed, okay, in between P and F somewhere, which is AB. So light ray, let us see after reflection from this object where they meet exactly. So one ray, if I take parallel to the principal axis, I know that it is passing through focus. Now if we consider another ray, keeping in mind that this is passing through this is along the center of curvature, then it will retrace back in the same medium, in the same, along the same path. So this path will be like this, the path will be like this, and this is the ray, and these two rays are going wider, and they are not going to meet anywhere when extended further, right? So but when traced back behind the mirror, both the rays are appearing to meet somewhere behind the mirror. So that will be your image. This is A dash B dash, right? So when light rays coming parallel to one ray after reflection passing through focus, Okay, another ray we are taking, and that is along the center of curvature. So we see that these two are not going to meet anywhere, but when traced back behind the mirror, it is appearing to meet there. Where, and of course these two are acting like reflected ray. Okay, so we feel like light ray is meeting there, and from there the light rays are coming. Okay, these two light ray are meeting here, where image will be formed. And I'm telling you, this is the virtual image. Why? Because this is not meeting by actual main line, actual bold line. This is meeting by dotted line. You can see dot line is there. Okay, so this way you can consider whether the real image is there or virtual image there, just by looking. If it is by dot line, it is virtual. By main line, it is real. And real image is formed by actual meeting. Real image is obtained on a screen. This image you can't obtain on a screen. Early morning, when you get up in the morning, early morning when you see your face in a mirror, a plane mirror, that image you can't take on a screen, right? That is the plane mirror. And what image you are seeing yourself, of course, that is virtual image. So here one of the case is there in a concave mirror, where we are getting a virtual image. So if this question is coming, that name a mirror which always form virtual and magnified image, then you must say concave mirror. And when they will ask name a mirror which always form a virtual erect and diminished size of image, then you go for convex. And what if they are asking name a mirror which always form virtual and same size, then it is plane mirror. And this is how you can distinguish the mirror, right? Placed in front of you without touching. You keep yourself in front of the mirror, okay, and if you see, you observe that if the image is same size, then it is plane. If the image is bigger, you consider it is concave, and if the size of image is smaller, right, then it is convex mirror. And this question NCERT जो है, I mean CBSE जो है, asking this question also. This question is there, and this question is there in your textbook, right? How you will distinguish the kind of mirrors. Okay, so this is case number 6. Now no need to disturb. You can disturb this image also if you will consider more light rays, this ray, this way, this way, this way. All the light rays, they are not going to meet, okay, and this ray, okay, after reflection all the light rays will be meeting exactly after tracing the जो है rays, okay, behind the mirror only, behind the mirror only, okay, where a image will be formed. So this is how it look like. Okay. I hope you understand. So this is case number 6. Now we can go for convex mirror. So concave mirror, we have seen how the nature of image vary depending upon the position of object, of course, placed in front of the mirror. Okay, so what is the characteristics of image formed of an object when placed in front of the mirror? It is only on depending upon position of object. We can see how when the object was placed at infinity, image was formed जो है at focus, and when you are making the object जो position of object little closer to the object, and images जो है size of image जो है goes on increasing, right? So here in concave mirror, size of image is increasing, and of course in convex mirror you will see image how the size of image is decreasing. So let us go for convex mirror. Right, in convex mirror, okay, first let me write here. So basically in convex mirror, two possible cases are there. Okay, Why? Because in convex mirror focus is placed there, other side, so no other position left, okay, other than these two. One you can place the object at infinity, another one you can place object anywhere beyond pole on the principal axis, of course. So these two possible cases are there where you can place the object so that its image will be formed. So let us see one by one. So case 1 we are discussing. Case 1 first, when the object is placed at जो है infinity. So this is case number 1. Of course in convex mirror I am talking about, okay. So let me consider one convex mirror. This is one of the mirror, okay. This is pole P, focus F, and this is center of curvature. Now light ray coming from infinity, okay, assume to be coming parallel to the principal axis or else parallel to each other. So I am considering these two at first. You see these two light rays are coming from infinity. Of course they are parallel to the principal axis, and we have read that rays coming parallel to the principal axis, after reflection they are meeting at focus. Either they are meeting exactly or appears to meet. So here in this case these two rays will appear to meet at focus. You see these two rays are appearing to meet at focus exactly. Yes, na? So here image will be formed now. Why? Because these two rays now I am considering the reflected ray. So here and of course it is appearing to meet from at this point. Light rays appear to meet coming out of this point. So this point contribute the image. So here what is the position of object? What is the position of object? Position of object is at infinity. And what is the position of image? The position of image is at focus. And what about the nature? What about the nature of image? The nature of image is going to be virtual. Why? Because light rays are not meeting actually, okay na? Light rays are not meeting जो है actually at a point. In fact it is meeting virtually. So this is the virtual meeting. This is not an actual meeting. I have said already that actual meeting means main line, bold line, or virtual meeting means dot line. So here it is dot line meeting. So it is virtual, and virtual means erect and highly diminished. DIMINISHAD. So diminished. So this is the position of object, position of image, nature of image. These 3 points you definitely write and mention for the diagrams. So this is case number 1, when the object is placed at infinity. So assume that light ray is coming from infinity. After reflection, since these two light rays are parallel to the principal axis, so after reflection they will appear to meet at a point. I mean, when traced back behind the mirror, it will appear to meet at this point where a virtual erect and highly diminished image is being formed. Now if you consider more light rays, okay, this one, more number of light rays you will consider. You see after reflection they all are meeting exactly at this point only, okay na? So this way it will go. So all the light ray will be appearing to meet at this point only, where image will be formed. So this is case number 1, when the object is placed at infinity in case of convex mirror. Okay. Now moving on to the case 2 in case of convex mirror. So what is case 2? So here only I am writing case 2 when the object is placed. Actually, you tell what is the possible position left. No other position left. One you can place at infinity either or somewhere beyond pole. Pole के सामने में कहीं पे भी तुम ऑब्जेक्ट को रख सकते हो. Here, 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 here. All are counting same case only. ठीक है? Okay. So second case is when the object is placed beyond pole. मतलब पोल के बाहर कहीं पे भी पोल के बाहर, पोल से परे you can place anywhere, right? You can place anywhere. So case 2 is, let us suppose one of the mirror, and this is the pole, this is dash, this is focus, and this is center of curvature. You consider this is center of focus and this is center of curvature. Principal axis dash. So I am considering one object to be placed beyond its pole. This is one of the object AB, and you know one ray I am taking is always parallel to the principal axis. Why? Because I know after reflection it has to pass along focus. When traced back, it will appear to meet at point focus. Now another ray is very simple. Okay, this one I am taking, which is of course I know that it will retrace back along the same path. So why I am taking this? Why? Because it is passing along the center of curvature. So when traced back, it will appear to meet here, and here this way I am getting a meeting point. Yes. So if it is AB, then this will be A dash B dash. You can see here height of object is means in upward direction, and height of image is also in upward direction, and of course it is erect only. So what is the position of object? Position I will write beyond P, and what is the position of image? I will write between P and F. So for that I am writing B/W, P and F. Okay. And what about the nature? The nature is virtual. Why virtual? Already I have discussed, meeting by a dot line, not meeting by actual main line, and it is appearing to meet, not actually meeting. Okay. So virtual, erect. Virtual means erect, and diminished. Don't write highly diminished. Diminished. So virtual, erect, and diminished. This kind of image is formed. So when someone will ask you name a mirror which always form a virtual, erect, and a diminished image, so only one answer is convex mirror, because in convex mirror in all possible cases diminished size of image will be formed. So what about magnified image? Can go for concave mirror. Same size image go for जो है virtual, go for plane mirror. Same size real, go for concave. Same size virtual, go for plane. And bigger, magnified virtual, go for, in that case also go for concave. And diminished, smaller size and virtual, go for convex. Clear? Here these two rays I have considered. If you will consider more number of rays like this, in all the cases, okay, after reflection they will be meeting exactly at this point only. At this point only. You can see here, you can check out here. Seeing now how this satisfying look. So this is the case 2. Okay, case 2 is what? When the object is placed beyond pole. And what is the position of image in this case? Back side. Of course front side is object is placed, back side in between pole and focus. And what is the nature? So bhai virtual, erect, and same size. Now tell me, what is the magnification you are thinking here? Tell. Magnification. What is the magnification? Of course, here magnification, see, h dash is less than h. Height of image is less than height of object. So this is the height of object and this is the height of image. Height of image is less h compared to height of object. That means m value जो है, that you know that m is equal to h dash by h. So m value is going to be less than 1, right? Less than 1. And if m is less than 1, that height of image is less than height of object. If m is more than 1, that means height of object is bigger h compared to height of object. So this way you can go for. Okay, so that's all for today.